Welcome back to Applied Algebra. We are moving on in the Polynomials chapter. And in this video we're going to be doing addition and subtraction of the polynomials. Within this section, some of the things we have to work on are terminology. So as you can see here at the top, there are some terms: monomial, binomial, trinomial. So if you think of the term polynomial, poly means many, and nomial just means term. So we're talking about many terms. Monomial, mono just means one, and so a monomial is a single term. A binomial, if you think of things like a bicycle, a binomial has two terms. And a tri, like a tricycle, has three terms. Now you might be asking yourself, how do you know where terms start and stop? Terms are separated by plus or minus signs. Another thing that is important is, how do you know what the degree of the polynomial is? The degree tells us what the polynomial represents. If the degree is a 1, then it is a linear polynomial, makes a straight line. If it is a degree of 2, then it is a quadratic polynomial, and it makes a parabola or a curve. And that keeps going on the 3, a 4, and so on. So when we're talking about the degree of a polynomial, we're talking about the highest exponent in any one term. So let's look at these down below, these examples. We're supposed to classify each expression as a monomial, a binomial, or a trinomial. Remember, they're separated by plus or minus signs. I do see a single plus sign here, so I have two terms. Two terms is a binomial. In this one, I do see a negative sign, but it does not count. It's not really something subtracting something else. So this is considered one term, so it is a monomial. In C, I see this being subtracted and this being added. So I have 1, 2, 3 terms, so this is a trinomial. We only have terms for the first three: monomial, binomial, and trinomial. Anything with more than 3 terms we just say is a polynomial. So if we were to state their degree and arrange them in proper order, so highest exponent to lowest exponent, so the degree of any constant is 0 because there's no variables. The degree of this x is 1, x to the first, so that has a degree of 1. This term has a degree of 2 because its exponent is 2. Whoever has the largest exponent is the one that's the degree of the expression. So this is a trinomial that has a degree of 2 because that's the highest exponent. Now if we put them in order, we always start with the highest exponent, so that's x squared. Then we go to the next one, which would be x to the first, and the subtraction sign belongs to this x, so we're going to minus the x. And then any constant will always go last. There's no sign in front of it, but we know that this is a positive one, so we're going to say we're adding 1. In the example B, we have 4 terms. So we're looking through to find the highest exponent, and that is the 3. So that is our degree of this expression. It's a third degree. It has 4 terms, but it is a third degree. Now we're going to put them in order. Highest one first, so 4y cubed minus 6y squared minus 3y plus 7. In example C, we only have two terms. It is a binomial. Remember, constants have a degree of 0. Then I have this one, which has a degree of 5, so the degree of the expression, it would be a 5th degree. Now I'm going to put it in order from highest degree to lowest. So the x to the 5th, see how it has the subtraction sign in front of it? So it is a negative x to the 5th, and there's the invisible plus in front of the 1. Now we're going to go ahead and just do some adding and subtracting. I only have a couple examples here. There are more in your textbook, and if you have questions, let me know. So we're going to find like terms, which we have already done in the previous sections of this chapter. Whenever you're adding different parentheses, they really don't do anything. They're just showing you it's this trinomial plus this trinomial plus this trinomial, but the addition doesn't do anything to the sign, so I'm just going to look for like terms. So I have 3x squared, negative x squared, minus 2x squared. So 3 minus 1 is 2, 2 minus 2 is 0. So I have no x squareds left in this expression. Now I have a 4x, negative 2x, and a positive 2x. 4 minus 2 is 2, 2 plus 2 is 4, so I have 4 x's. Now I'm going to look at my constants. I have a negative 5, a positive 2, and a positive 7. Negative 5 plus 2 is negative 3. Negative 3 plus 7 is positive 4. So I put all of those together and I end up with a binomial of 4x plus 4. So whenever you're doing any adding of expressions, you can just really remove the parentheses and follow the signs. Now if you are subtracting, that is not true. You do have to pay attention, and I always put a 1 here and use the idea that we did in the last section, where if I have a negative 1 in front of a parenthesis, I'm just going to distribute it. I get to remove the parenthesis in the first expression. It's doing nothing. So it's 20y squared minus 17w, 20w squared minus 17w minus 6. Now I'm going to distribute. Negative 1 times 13 is negative 13w squared. Negative 1 times 7w is a negative 7w. So what you should notice is that when you are subtracting an expression, all of the signs of the parentheses should change to their opposites. Now again, I'm going to look for like terms. 20w squared minus 13w squared is 7w squared. Negative 17w minus 7w, negative 24w. My 6 is the only constant, so I just minus 6, and that ends up being that trinomial. If you need me to send more examples, please let me know. Otherwise, go ahead and work on your assignment, and I'll look forward to grading your paper. Have a good day.